Hello, everyone. I hope you're enjoying the conference so far. My name is Vishnu Prasad Kumar, and I'm a supply chain management solution architect, primarily focusing on warehouse management, optimization, and automation. Today, I would like to talk to you about site reliability engineering for supply chain management, which can be used to build reliable warehouses, making use of the human and AI factors, combining them, and then making the warehouses more reliable to meet the growing demands of today. Let's get into it. During this session, whenever you're watching the session, if you have any questions, please feel free to reach out to me. You can connect with me on LinkedIn. I'm always open to answering questions. All right. So now let's talk about supply chain in general. Now, supply chain, to simply put it, is to transport goods from point A to point B. Right. That's the most simplest of explanations anyone can give for supply chain management, to take items from point A to point B. Now, what people outside of supply chain do not understand is how difficult it is to get items from point A to point B is, and what happens in those huge buildings trying to take items from point A to point B, right? That's what supply chain is all about. And that is my area of work, where we try to optimize the systems, optimize the processes, make efficient business practices within the warehouses so that the point A to point B transfer can be done effectively, economically, and quickly. So, in today's world, with e commerce, the boom in e commerce, right? People are purchasing stuff online all the time. And the demand for fast warehouses, fast shipping, fast order processing has grown multifold. So, that has resulted in unprecedented growth in the supply chain space. Now, when we talk about the recent advancements in supply chain, we talk about integrations with IoT sensors, we talk about integrations with AI, we talk about digital twins, we talk about all that, right? But what we don't gently talk about is how supply chain management and how warehouse management is not getting the attention that other areas get, say, like cloud systems, right? It's something that many companies or many organizations neglect or do not pay much attention to, and then end up trying to optimize it at a later stage. So, that is something I would like to talk about today. Now, production grade reliability practices is something that we're focusing on, where I'm going to talk about how these systems need monitoring and optimizing early on, even when these systems are being designed and put in place, even during the implementation phase of these systems. If you can incorporate these components into it, how it can turn the system and the overall warehouse efficient, the overall supply chain efficient. And we'll also be talking about how the system can incorporate both the human and the AI elements, combine it, and then use it to give much faster, much efficient throughputs, right? Now, what's the challenge in modern day warehouses? Now, one of the most critical areas of it is the number of layers involved in today's warehouse. We have a system that takes care of the inventory management, takes care of all the stock monitoring and all that. We have a system that takes care of transportation management. We have a system, if there is a 3PL involved, we have a system that takes care of 3PL. We have a system that takes care of procurement, sales. There are all these different systems and maintenance, production, all these different systems that work together, and they're all integrated to the warehouse, and they're all integrated and are part of the overall supply chain process. Now, when it comes to it, regular proven methods that we have been using so far, where we have been doing manual interventions to do picking optimizations, to do route planning, to do demand forecasting, all of these have proven to fall short to cater to the growing demand of today's consumers. So that's where we're trying to include AI driven optimizations. We're trying to bring in autonomous systems, robots that can pick. We have automated storage and retrieval systems that can go up and down high racks, reducing work worksite incidents, increasing safety for workers they don't have to go up all the way up to the high rack area and pick it themselves. We have automated systems for it these days. Many companies are using it. Now, some of the areas where we can improve it is AI driven optimization, where we can talk about how picking algorithms can be optimized and made efficient, how route planning can be done so that maximum efficiency is obtained when planning an order that is being shipped, how demand forecasting can be done using AI models, where based on seasonal demand or based on any other types of demand or low demand, how the procurement can be done or how production practices can be adjusted based on the demand. And we obviously talked about the autonomous systems, robots and retrieval systems, automated systems within the warehouse. And of course, we still need the human touch within the warehouse where they'll have to go through quality. We'll have to go through exception handling, all that still needs the human touch. And also any task that requires judgment still needs to go through the human touch. And then we also have predictive maintenance, where a lot of these sites do run 24/7, and we cannot always go into a breakdown maintenance. Rather than, we should always plan ahead, see what type of maintenance these equipments might need, so that before something breaks down and causes a production loss, we're always ready to do predictive maintenance, preventive maintenance, and then make sure that we are not having that downtime. That is also something that can be achieved with the sensors and integrations. Now, again, I did talk about how traditional monitoring falls short, because when we talk about traditional models, it always involves a manual input. It always involves someone going into the warehouse or someone going into one of these production facilities or maintenance facilities and then seeing how the machines are doing, how the components are doing, how the equipment's doing, and then deciding if it requires a maintenance or if one of these items needs more stock or if one of these items needs less stock because the demand is not that much. It is all based on manual judgment. And in high volume warehouses, it is just a lot of data to go through. And also, all of this is based on, just like I said, human judgment. So we do tend to miss subtle changes that can happen, which at that time might not be huge, but then down the line, it can have a big impact in how we manage and run the warehouse, right? So these models, if we train them and if we have algorithms in place, it can catch hold of these subtle changes early on and then let us know if we have to make those adjustments in our process so that we are ready when those changes in the demand comes or when that change in the overall supply chain process comes in, and when we have to talk about or when we have to go into that maintenance mode when a certain item requires a fix. If these models and sensors are able to give us that information beforehand, we would be able to have that predictive maintenance and reduce the overall downtime and increase production throughput. So that's where the traditional models fall short, and that's where we'll be talking about using all of these sensors and algorithms, which can help us run our warehouse in a much more efficient manner. That's what I'm talking about. Okay. Now, some of the core elements when you want to implement such a model in the warehouse is first you need to identify your service level indicator, right? You need to understand what you're trying to achieve with this model. Do you want to increase your picking accuracy? Do you want to increase your inventory accuracy? Do you want to increase or decrease the number of times you go to pick an item and then find out that the item is not there? So that is something that falls under inventory accuracy. Do you want to reduce the number of such occurrences, right? What is your service level indicator? What is something that you're trying to achieve with the system? And then you need to have error budgets. You need to have tolerances on how much of certain thing is tolerable. You need to tell the system that I can have up to 10% variance or I can have up to 5% variance. And then you need to also talk about automated remediation, where if, say, for example, you go to a certain bin in a warehouse, you try to pick an item, and then you go there and then realize the item is not there. But the system tells you that the item is there, but physically it's not there. Now, what happens? You need to block the bin. You need to tell the system that something is going on. The item is not there, but the system keeps telling you that the item is there. And then you need to go into that exception handling mode. And then what happens? after the exception is raised, how it is handled, what kind of investigation is done, and all that. So we need to have that automated remediation also built in. And then we need to also talk about observability pipelines, right? How we can observe the components and machines and equipments that are working in these sites, how we can gather information from those sensors, and how we can make use of that information to make sure we are doing predictive maintenance, right? Now, let's talk about the sensors for a bit. Now, we're talking about IoT sensors, right? Internet of Things. We have various types of sensors, like mentioned here. We have temperature, motion, weight, which keeps monitoring these systems, these equipments, these machines 24/7. And it has various aspects of monitoring that it does and various indicators that it keeps giving us as an output. And if something changes based on the change in the indicator, we would be able to determine if that specific machine or piece of machine needs to go through any sort of adjustment, needs to go through any sort of maintenance, any sort of replacement. So by using this information beforehand and by having this update beforehand, you would be able to fix it before it breaks. So that's what we call predictive maintenance, right? And also preventive maintenance. So if something breaks and then you try to go fix it, you need parts for it, right? You need to order parts for it. You might not always have it in stock to fix something. And then you need to wait for the parts to come to you. So that's going to take time. So that's why we talk about predictive maintenance. We're like, okay, I'm just going to fix things before it breaks. I'm just going to constantly monitor it and then fix it before it breaks so that I can avoid production downtime. Because when a machine goes down, when one of these components go down, these sites, which which usually run 24/7, one of these machines, you have to shut it down until you get a replacement component and until you can fix it, the machine is going to be shut down. That causes production loss. And based on what kind of industry you're in, it can be a huge loss, right? Or you cannot predict how long it might take a component to be fixed. There could be supply chain disruptions. So that's why predictive maintenance is an important component of these high velocity sites, right? And based on the information from these sensors, you can always train the algorithms. You can have vast amounts of sensor data analyzed, and it can keep telling you if something needs to be changed. And then we can talk about the basic KPIs that needs to be monitored. How soon you're fulfilling your orders, how soon you're picking, how soon you're sending stuff outside your warehouse. From the time you received a customer order, by the time somebody goes to your warehouse and picks it, and then by the time it leaves your site, it's issued out, and then it's on the way to its customer. You can track these times to make sure that you identify any bottlenecks in this process and then make sure that you're also optimizing the process so that the overall customer satisfaction is also improved and you don't have any holdups in your overall process because something is not working the way it is supposed to. All right. And then digital twin. So that's something that's being used widely in the supply chain area, simply because when it comes to supply chain management and warehouse management, we have various softwares that are being used to handle activities, day-to-day activities within the warehouse. Again, just like I mentioned, we talk about inventory handling, where all the inventory is stored. We talk about picking, where you pick stuff from your warehouse, issue it to a customer order. You do put away, you receive stock from the vendor and you store it into the warehouse. You do internal movements within the warehouse. And then you talk about inventory accuracy, where you go do cycle counts, right? You count and make sure that your entire warehouse, the stock levels are good. It is as per what is there physically in the warehouse is what is being reported in the system, right? You do all that. Now, if you take a high velocity warehouse where a lot of these activities are happening on a day to day basis, any implementation, any change that you do, any new system that you try to implement is going to cause a disruption because it's just brand new and the volume is too high, right? And even when something changes, a pattern emerges, right? Say, for example, there is a high demand for a specific material, and then you suddenly get a lot of orders for it. Or there is low demand suddenly the demand drops because of, it could be various reasons. It could be natural calamities, or it could be geopolitical reasons. It could be anything. So demand can rise or go down. And during those situations, how your warehouse handles those situations, how your warehouse handles the volume is something that you can only say when you go through it, right? So that's when digital twin helps, where you can create a digital twin, a copy of your warehouse, and then simulate these variations in the business process and then see how your current process is holding up. Say, for example, you can test, just like I said, you can test a high demand scenario and see how your warehouse or how your current warehouse setup, how your current system setup is built, sorry, is able to cope up with that kind of a demand, right? So that is when digital twin helps in the overall simulation, and then you can review the results, and then you can decide which areas in your process, which areas in your system needs refinement to handle those changes, right? Now that's a replica. That's what I'm talking about. Now let's talk about analytics and predictive maintenance a little bit, right? So the first step is that you need information. You need a lot of data to do the analysis and then come up with predictive and predictive maintenance schedules. So the first step is data collection. You need seasonal patterns to identify when a material can be in demand and when a material can go out of demand. You need to think about the trends, the growth trends, and then you need to go to predictive models where machine learning models will identify these capacity that in which your warehouse is operating, incorporate the data collected, run simulations, and then tell you this is when you might go through a high demand phase, and this is how your warehouse is equipped to handle the volume, high volume or less volume, right? How your warehouse is equipped to do that. And then you can also talk about automated alerts and recommendations on how your infrastructure is currently holding up and how your infrastructure might need some kind of a change to accommodate, say, an upcoming change that can be really big. And if your warehouse is not ready for that kind of a scenario, then these models can let you know, and then you can make those changes. Now, talking about these automated systems, we need it goes through several steps through the process, right? So the first is detection. We need to know what, when, right? And then the diagnosis, why, the remediation, what happens next, and then the verification, what was done to fix it, did it really solve the problem? So the first step in the process is detection. Now, in that step is when you monitor the system and then you try to identify if there is a failure or if there is a degradation in the performance, right? That's when you get into the predictive maintenance mode. If it is a failure, it goes to breakdown maintenance. If it is a performance degradation, then we go into the predictive maintenance model. And then we go to the diagnosis. Now, based on the information detected, we go and check and analyze the data and then decide if it's going to be a breakdown maintenance or if it's going to be a productive preventive maintenance to make sure that the production is not interrupted. And then we see what kind of an issue it is. Is it a component health issue? Is it a connectivity issue? Is it data inconsistency? Is it a volume issue? Is it a process issue and all that? And then we talk about remediation. We talk about steps that we can take to make sure that whatever anomaly that was just detected, whatever issue that was just detected is not going to cause harm for the business and not going to cause production outages and cause revenue loss. Now, we can talk about a bunch of self-healing or automated responses to these anomalies. Now, in here, sorry. Now, in here, when these items or when these anomalies occur, there are certain steps that the system itself can take just to make sure that that situation is averted. But that can not always be the case. So we should also build that human factor into it so that there is someone who is always overseeing these actions and making sure that there is a human judgment factor to it, just to ensure that whatever action is being taken is the right course of action for that situation, right? So that comes into the verification model. Just because you throw a bunch of resources at a problem doesn't mean that the problem is getting resolved, right? You need to make sure that you throw the right resources at the problem so that the problem is resolved, and then that it is also a permanent fix to the solution and it's not going to happen again. And then we also have some best practices that we can follow when you're going to implement a new system or when you're going to implement a change in one of these high volume sites. So what you can do is always make sure that any change that you do version control. So if something is breaking, if something is not working right with the new version, you can always revert back to the older version. And then you should always do multiple rounds of testing, be it unit tests, integration tests, user acceptance tests, right? Load tests, performance tests, all sorts of testing needs to be performed when you're implementing a new warehouse system. And then the type of implementation that is being done is also an important factor. You don't do a massive implementation of a big scale all in one go. You do incremental implementations, you do incremental rollouts, making sure that you do the first phase of it, you observe, see that it is successful, and then you go to the next phase of it, implement it, observe, see that it is successful, and then you go to the next phase, right? You don't do all at once, because if something fails, you don't want the entire network within your organization to fail because your implementation did not work out. And then you also don't want a lot of downtime for your warehouses during these system implementations and during the system changes, right? Because just like I said, all of these high volume and high velocity warehouses, a downtime means it could mean millions in lost revenue, right? So you cannot afford to have that kind of downtime. So whenever you do that, you need to make sure that you're minimizing your downtime to the maximum extent possible, and then making sure that you're not disrupting live activities within the warehouse and you're not disrupting the supply chain activities. Now, you need to, when we talk about these automated systems, where you can have human AI collaboration and the system suggesting changes, suggesting fixes, you should also talk about how if something did not work, something that the system suggested, something that these models suggested did not work, how do you make sure that it is fixed? How do you make sure that, how do you make sure that it is refined? How do you make sure that it is working in the next instance that something like this happens, right? You need to do an initial assessment on what happened, why it failed, and what was the impact of the failure, right? That is the first thing that you need to understand. The second is you need to have a manual workflow where somebody from the warehouse or somebody from the supply chain organization is able to go look at it and then say, okay, some of our systems failed. There should be a fail safe mechanism that needs to be triggered now. I need someone to go look at the problem and then come up with a solution for it because the system was not able to come up with a solution for it, right? And the root cause analysis, we need to find out from where the problem was. Was it a problem in these models running the analysis and giving us outputs? Was it a problem connecting these systems to the warehouse management system? Or was it someone or in the warehouse or in the overall supply chain model that we have training gaps is not able to do their job the way that they're supposed to do, right? So we need to find out where this problem is coming from. And then we need to talk about system restoration. How, if such a failure happens, the system can be restored and brought back to an extent that it is functioning at the same level as it was just before the breakdown, right? So we need to make sure we validate the fix that was being applied. We need to make sure that we validate the performance right after the fix. And then we monitor the situation, and then after we fix the identified gaps, we gradually transition back into the automated operations model, right? And then we do a post incident review where we try to understand the entirety of what happened, why something did not work, what can be done to fix this scenario if it happens again in the future. A lessons learned review that we need to do so that we can prevent a future recurrence of the same issue. Now let's talk a little bit about actionable frameworks for these platform teams, right? Now we have, just like I said, supply chain management needs production grade frameworks, right? That can help them have reliable warehouses, scalable warehouses, and scalable warehouse systems, right? So one of those items is SLO template. So we need to have ready to use service level objectives so that it is tailored for the warehouse operations, observability architecture, integrating IoT sensors, integrating temperature sensors, integrating weight sensors, integrating it could be RPM sensors, and getting back all that information, analyzing that information, and then coming up with suggestions on if everything is good or if something needs maintenance and all that. And then we have automation patterns that we can talk about where we have workflows. If something happens, what the system has to do, if something is still not right, if it has to go through a manual override, if it has to go through an exception handling process, if it needs to get somebody involved, and all of that control mechanism that is built into the process. And then it's to talk about how to build a production grade supply chain infrastructure, right? Now, like I said, supply chain is a critical component of any business that is involved in sending and receiving goods, right? Now, by applying these site reliability engineering principles to warehouse operations, these platform teams can create predictable, self-healing, automated fulfillment systems that can scale with business demands because, again, it has all that information to look at the forecast, look at the demand forecast, and make all those decisions. And then we can make use of these integrations to make sure that we maintain high service levels, we adapt and change to growing business needs. We always maintain higher customer satisfaction, higher customer retainment, and make the overall supply chain process efficient, right? So that's where these practices come into picture, and that's where these practices can help any supply chain organization succeed and keep succeeding in what they're doing. That is everything that I wanted to talk about today. Thank you so much for listening in. Again, if you have any questions, please feel free to reach out to me on LinkedIn. My name is Vishnu Prasad Krishna Kumar. I hope you have a wonderful rest of your day. Thank you.